In the previous lesson, we looked at general shapes of functions. Now we're going to actually graph them specifically. So we're not just going to do a sketch. So example 1, model the function y equals negative 1/2 x plus 1 with a table and a graph. So this is a table of values. Now, you can make a table of values for any function. What you need to do is make an x column and a y column. Right here, I'm just doing this to show my work. But for any function, you can plug in values for x into the function and get y, and then make your graph. So it helps to know the general shape of it to when you graph. So we know that it's going to make a line because it's just an x value over here, and that it's going to go down from left to right, and it's going to start at 1. So if you're graphing your points and your points are not going to make a line, then you know that you did something wrong. So to make a table, what you do is you pick values of x, you substitute the values into your function and see what y is to get an ordered pair. So I'm going to substitute -4 in for x. So it's negative 1/2 times -4 plus 1. So that's going to give me 3. So then my ordered pair is -4, +3. Second one, I'm going to plug in 0. So it's -1/2 times 0 plus 1. So I get 0, 1. Next, I'm going to plug in 2. So it's -1/2 times 2 plus 1. So I get 2, 0. Because -1/2 times 2 is -1 plus 1 is 0. So if I go over here and graph this, I'm going to plot the points -4, 3, 0, 1, and 2, 0. And I'm going to connect to make a line because I know it's a linear function. So we have talked about with inequalities, discrete and continuous situations. So assume functions are continuous so that you can actually connect the dots if there is no context to the question. And I'll show you an example on the back of one that's not continuous. It's a discrete function. So example 2. Suppose a car gets 22 miles to the gallon. The distance traveled d of g is a function of the gallons of gas used. So here's your function rule. D of g equals 22 times g. So is this relation discrete or continuous? So can you pick all values of gallons, or do you buy a gallon at a time and one gallon at a time? For example, you can only buy 1 gallon, or you can only buy 2 gallons, or you can only buy 3 gallons of gas. No, it's continuous because you can buy, if you go fill your car up with gas, you can buy all different decimals of gases. So it's continuous. So then what I'm going to do is I have this table of values, and I'm going to plug in G is 0, G is 2, G is 5 to get a set of values. So if I plug in 0, I get 0. If I plug in 2, I get 44. If I plug in 5, 22 times 5, this is 10, carry it. 5 times 2 is 10, 110. If I plug in 10, I get 220. And if I plug in 15, 22 times 15, 5 times 2 is 10, carry the 1 over. 5 times 2 is 10 plus 1 is 110. Add a 0 because I'm moving over to the 10 spot. 1 times 2 is 2, 2 times 1 is 2. So this is going to be 330. Or I could use the distributive property and did 22 times 10 plus 22 times 5 and got 330. So then I'm going to draw my graph. So my independent variable is gallons. And my dependent variable is gas, or distance. So I'm going to put, my scale needs to include 15. So I need to make sure I'm going up to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I lost my spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. 11, 12, 13, 14, 15. So I'm including 15 gallons. And then I need to come up with a scale that includes 330. So I'm going to go, this will be 100. 1, 2, 3, 4, 5. This will be 200. 1, 2, 3, 4, 5. This will be 300. So then I'm going to plot my points. And we know it's going to be a continuous graph, so we can connect the points. So 0, 0, which is probably sloppy. So 0, 0 is right here. 244 would be about right here. 5, 110. 2, 3, 4, 5. 5, 110. 10, 220. 200. I had to go up by 5, so this would be 220. And then 15, 330. 1, 2, 3. Just past 320. So when you connect it, you can connect it because you can have decimals for gallons and distance traveled. I don't want to connect it all the way this way because that would infer that it's negative gallons and a negative distance. So I'm just going to start it at 0 right here. And then make sure I answer the questions. So should we connect our points on the graph? Yes. What is the independent variable? Remember, this goes on the x-axis. So this is gallons. And the dependent goes on the y-axis, and it's gallons used, or gallons of gas. The admissions to a fairground is $3 per vehicle plus $1.50 per passenger. The total admission T of n is a function of the number of passengers n. So the rule is T of n equals 3 plus 1.5 n. So if you had, this would be a discrete situation because there's no way that you could get all different options for money. So you could not go to this fairground and ever pay $4 because if it's $3 a vehicle plus $1.50 per passenger, you would never get to $4. You would have $4.50. You could never spend, let's see, you could never spend $5 either. So they're going to be at different increments. There's only there's only certain amounts of money that you could ever spend, being that it costs $1.50 per passenger. So you should not connect the graphs, not connect the points on the graph. The independent variable is your number of passengers, because the cost depends on the number of passengers. And then the dependent variable is on the y-axis, and that is the total admission or cost. Usually cost is always a dependent variable. So I'm going to put that the admission, the number of passengers is right here. And then the admission is on the y-axis. And then I'm going to fill out my table. So if nobody is a passenger, which is kind of ridiculous, it's going to cost $3. Right? Because your car's still going through. I don't know how, but I'm just filling out my table here. So if you have 2 passengers, each passenger was $1.50. So that's $3 plus $3 for the car, so that's $6. If you have 5 passengers, 2 passengers are going to be, or 4 passengers is going to be $6. Then add another passenger on, that's going to be $7.50 plus 3 is $10.50. And then if you have 7 passengers is going to be, well, 6 passengers will be $9. So this will be $10.50 plus the cost of the car, which will be $13.50. So we're gonna make sure our scale, make sure your scale includes 0 to 7 and then 3 to 13.50. So I'm just gonna go up by 2. So this will be 1 passenger, 2 passengers, 3 passengers, 4, 5, 6, 7. And then over here, the cost, I'm going to go up by, let's see, I'll go up by, this will be 4, going up 4 more. I'm just going up by 1s, I guess. This will be 8, and this will be 12. Your scale can be different, of course. So then I'm going to plot 0, 3, which is right here. 2, 6, 5, 10, 50, and then 7, 13, 50. Now, I could also take my time and plot the dots, and I should, but I should plot the dots in between here. Like I should figure out 1 passenger, 3 passenger, 4 passengers, 6 passengers, and plot the ones in between here too, because you should actually include those as well.